How's it going, everyone? Welcome, Eulier Gonzalez here. So in this video, I want to make a quick recap of how do I get here by exploring at the mutability, but this is the course of taught by Matt Pocock, a software engineer that previously worked at Vercel, a company that now provide solutions to clients to host their web applications on AWS infrastructure. And particularly here, if you are going to provide this kind of services like web servers, applications, and so on and so forth, to make things more scalable, because at the end of the day, the web server or the way of how we can now share content from one place to another, as long as it lives in a computer, right, is in our case using the hypertext and hypermedia transmit protocol. So this is a mechanism of how we can now share these particular documents, hypertext, which is a fancy way to say documents that have now content, but also image, videos, audio, and now interactivity, so like data visualizations and things that we can interact, right? So because it was originally created this network of computers at DARPA, this development defense advanced research, defense advanced research, defense advanced research development agency. Okay, makes sense. Defense Advanced Research Development Agency, the DARPA, as a response to what happened in 1957 when the Russians launched Sputnik, the first, how do you put it, the first satellites on orbit. So Eisenhower back then now create this agency as part of the backbone of the military branch with the government. So initially, these organizations focus their attentions on how you can detect now physical or nuclear tests. And there now emerge a new set of fields, which is geology, cosmology, among others. I don't remember all of them. But then it also makes this explorations or experiments of how you can now, by having this computer created by this particular company, the IBM, right, how you can make all of these different computers that live in different universities and other places communicate each other, particularly how you can get access, how to command and control a remote node on operations, and also how you can now transmit data or files among them. So this is the origin of the internet, all right? And there was a huge and collective efforts among several peoples to actually make this as it is, what we know as today. So because the problem with then is how you can control the network, and as the more and more nodes or computer are added to the network, how you can make sense as a network administrator. And this actually becomes quite problematic to try to have a centralized place where you can now control all of this node, which is interesting because this is part of the organizations of humans organizations and stuff like that. For example, like how do we organize in a state, or even for more close course, like, well, how you do that for your family, how you can communicate first with yourself, and then with your family, and then with your neighbors, and then with your friends and families, and then with your friends, and then at the state level, and then at the federal level, and then at the global level, right? So because this kind of challenge, as the more and more and more people added to your network, or in this case more and more nodes are added to a network, it becomes quite cumbersome. A bunch of smartphone, one of them is Vincent Cerf and Bob Ken. So they say, hey, instead of trying to control the network, let's take a look now at how do we communicate peer-to-peer. What is the process of communicate, the protocol? So that's why we have now the transmission control protocol, right? Which now it has indicating is, well, what is the communication? What is the port that you're going to use in order to transmit this data? And another thing is that now that you know this, so where are you going to send this data, right? What is the location where you want to send this data? Pretty much like a house and their zip code, right? It's like, hey, they already have that nice little a place to receive their emails. Okay, so in our case, in the case of the network, is the IP, the Internet Protocol, which allow us to identify is the address, the locations of these machines in this entire network. And with the TCP allows to this allows to describe is where, at which port or at which windows or door at that location we're going to send this data, right? And then you have now the data link layer and the physical layer, which is now how all of this data or bytes, which represent something. Usually they depend of what you want to represent, but those bytes can represent is numbers, or it can be representing strings. So for example, it can represent any symbol known for humans, or which is known as the basic multilingual plane, which describes all the possible symbols that we use to write to communicate, right? Whether it is Latin symbols or Middle East symbols or hand-based characters or even Cyrillic alphabet. That's what that's this particular map there, right? So this byte allows to represent is this kind of symbols known as a string, or numbers, or booleans, among other things, right? Or even objects. So the thing here is, this is the piece of information that you want to transmit over the cable, right? And because now we have is this particular architecture where you have now different computers that wants to communicate or send piece of data, it makes much more sense to try to describe what kind of data we want to send over, and that is what kind of document we want to send over, the hypertext document or hypertext media. So when you now look at the HTTP as this protocol to transfer hypertext over the network, this physical media, right? It makes a lot of sense to not only look at the spec, which I'm not gonna do that in today's video, but as you're starting to now build this application on top of these computers that allows to now send documents, sensitive information. So, for example, like bank accounts, balance accounts, or even more sensitive like intelligence, all right? Or perhaps more consumer applications, whether it is the a list of a shopping cart list, or perhaps a list of available service that you can go in your area. Okay, so in any of those cases, when I look at the HTTP and how now the TypeScript fits into the entire narrative, is the HTTP. And that is this application that is designed for transmit these hypertext documents. And these applications, in order to describe is the shape of this document, the hypertext, it is as an HTML, which is the structure, the CSS, how these documents are going to look like, whether it's on virtual media or in print media, right? So print, and as well as the functionality that we can provide to this document. Here, the logic that we can add to this document, and how compelling and how convenient is for these documents to describe certain scripts, all right, on how this document should behave, for example, right? And now this application, this HTTP, which is for serving content, so there also needs some application at the other side that actually can receive this document and render in a human readable way. This is known as the browser. That again is running on top of your computer. This computer that it has a particular architecture. I am not going to dive in today into this video, but this organization or this computer architecture that is made initially with the CPU. Hey, we have now this central processing unit to do basic stuff, you know. I'm not asking you to tell me the answer of the world or what is the meaning of life. No. Just basic arithmetic. Add, subtract, multiply, and divide. And also the running some logical operations, right? So to compare things. So this is the CPU, and also I need to somehow is to store data, right, close to the CPU, like RAM. Sometimes I prefer to store some data that I'm going to not frequently visit, all right, but I need to store them, like on disk, is the hard drive or SSD, or even sometimes I need to store that piece of information or that computation in another computer using now a network card, or I can now in this computer as a user, in order to interact with it, I need to have a mouse. Thanks Xerox for developing that. I also need a keyboard and some other peripherals like audio and cameras. Okay, so all of this is just to describe this basic underlying architecture that depend on the manufacturer, right? At the end of the day, when you run on top of this hardware and OS that is going to manage those resources for you as a user, to allow to run applications like the browser or an HTTP server. And in the context of this HTTP server, since we are developing these documents, this hypertext with HTML, CSS, and JavaScript, and it requires now certain organizations to make sense of maintaining these kind of applications, JavaScript's great for prototyping, but when it comes to try to scale that or to build now hypertext documents that is going to be used by millions of people, uh, or known as products, web products. So, for example, like social media or bank accounts or e-commerce. Uh, in any of those cases, uh, because no matter how big or small your applications, your web application is, what you want to serve to other people, right? There is a limit of how many. There is a limit here on how big things you can build on a computer. What are the economic incentives to build something on these computers? All right. Uh, how many people do you, or the physical constraints that we have in our computers, that you can't send data more faster than the speed of light. And also, so in terms of human aspect, is that how many people do you need to build this kind of application? So ideally you don't want anyone, right? But let's get real. You at least need one. So, and then I started to now realize that depend on the kind of application that you're building. So how many people do you need to be aware of this system, right? And that's when you have now size teams and perhaps team leads that are now in that make make the developing of this application feasible and easy to maintain as much as possible. So this is what now, for example, folks at Microsoft sits, all right? So they have a ton of experience building applications in C#. I really love the typesetting of that language, okay? For military and commercial industry, and as well as the finance. And then, because they need to actually now developing applications not only for computer exclusively, but for applications that share those documents, these hypertext documents, and make it easy to scale and to understand. So based on his experience building now app on C#, right? With this type safety, so anytime that you now read this script or this programs, you can understand is the author intentions. So you reduce the number of WTF per second. So now on that line, when you now build this kind of application at scale, at the Microsoft level, well, a bunch of small folks start a project known as the script sharp, or the sharp script, to actually combine the entire experience from C# into building now modular and reusable and easy to understand and maintains applications in JavaScript. So this is how now Typescript fit in here. Anytime that you need to build scalable applications, thanks to Microsoft smart folks and effort to make that happen. So people like me that live right now in Argentina and come from Venezuela, they can understand the value and also perceive some compensations on top of that. So whether if you are getting hired by a company in real estate or military or finance or any of these startups, right? So you started to understand how do you fit into this. So this is what Typescript is. I also look at the tools that allows to make this possible, right? So for example, a Typescript compiler, that what it's gonna do is to run a static analysis on JavaScript, because at the end of the day, JavaScript is a dynamic language, an interpreted language. it behave like a compiling. You can think of this like a at the current state 2026, JavaScript behave like a parsing, like a compile language. When it comes to parse that language, um, when it do this static analysis, because at the end of the day, so there are certain things that now JavaScript does. It's not right now in 2026 a interpreted language. It is a combination of a compiled and interpreted language. Why is this? To the evolution of JavaScript that makes now a certain statement or makes the JavaScript at the current state a two-phase language. Sometimes it or initially is going to perform a parsing phase and then the execution of that. But in any case, so this is what TypeScript is. In JavaScript, with the tool that we can go with TypeScript, at the end of the day, this is allows us to run this static analysis on JavaScript because it has this dynamic behavior. So TypeScript wants to run this static analysis so you can detect errors at compile time before it happen, and you can have nice little utilities like type settings or describe is the shape of the data, and also come with some additional features that you can use when you integrate that into your ID, right? So now this with this description of TypeScript, then I look at how can we use TypeScript at the current state in the web development in 2026 by see how you can integrate TypeScript with these front-end tools like Vite, where the TLDR is that it is a tool that allows us to speed up spin up a web server, it is spin up a dev server and a test environment, right? So then I look at what is the essential of these typings, and that is, well, it is important for us to understand the notations of the primitive of the JavaScript language. So whether it is the string, boolean, number, how you can also type now an object as well. How you can typing is functions, whether it's by giving it the parameters, how you can typing objects, and for the case of function is how you can now pass is optional parameters or how you can set require parameters. Also how in object typings how you can now pass these optional keys, or how you can make now optional values or optional keys, in how you define out typings, for example, with another built-in tools like map and set, some of the caveat using with map, also with arrays, typing with arrays or typing arrays, typing nested object and arrays, and typing callback functions, and typing promise, and the JSON parse here. So this is just the model here, the essential types and notations. How also because most of the web dev right now is using of an ID and integrated development environments. So luckily for us in Visual Studio Code, we have now this extension that allows to run a TypeScript server behind the scenes. So it's going to run this static analysis when we save our files or when we make a change on that. So this nice utilities functions that this TypeScript server provide is like the quick fix menu, or how you can organize your import or remove unused imports based on the selections of your based on highlighted selection. How you can now is how do I put it? How you can now, how the TypeScript server provide you some things to do, right? Or some hints about what you can do here. And also, well, at the end of the day, TypeScript is the TypeScript server is now evaluating those statements for you and how you can make sense of this statement when you read them, and how TypeScript errors now are split, whether it's at runtime, and sometimes the error is quite straightforward, and sometimes it's quite convoluted. So all of this is just to describe is how that integrate to that. And then now the notion of the TypeScript author, which is anytime that you need to describe is a piece of information of a system, whether it's you now enhance the functionality known as the union types that describe all the possible values that this variable can be, or you perhaps wants to now narrow down your narrow down to get only the proper data that you need to, right? So this is the notion of wideness and narrowness type, right? So that's why I look at, for example, is the any controversial, the never, the union type, how you can work with this in with defining literal types or object types, how you can combine this with the type or narrowing your type using the type of operator, or even if you want to only narrowing at an object level, and how you can also is use now that for narrowing is with, or how this narrowing works with map and set and all that kind of stuff, which is kind of like this, all right? And also and also how you can start to work with tuples here, how you can define or how you can type in tuples, how working with tuples is so convenient sometimes. And then now getting into the weeds of JavaScript behaviors like objects, immutability, classes. So for the object here, because the idea is with object is that allow you to describe and enhance the functionality of your application by having is the data and by having is the data and the functionality in one single bundle, right? Well, so TypeScript wants to describe is this kind of behaviors, and also leveraging the types here. So we can define now objects in types or interface. We look at how to do that in both cases, and the and what happened when you're trying to, for example, define is the same, and now looking at the behaviors at the object level. So for example, what happened when you have now the same object instance or the same name objects, how types behave, how interface behave. So types actually throw you an error. You say, no, you can't do that. So it behaves pretty much like when you define an identifier and a variable, like a const, all right? But interface now is trying to mash all of these definitions together. For example, in the functions overloads, or And another important difference is that sometimes um, you might find quite valuable. Okay, yeah, this is the types and interface. And another is that uh, when it comes to enhance the functionality of that object to provide more features, right? So in type you have now the ampersand, and in interface you have is the extends. So behind the scenes, the Typescript server, what it's doing is, hey, for any interface, I'm gonna catch that so I can now easily run the static analysis. But anytime that you use now a type with an ampersand, I'll have to compute that new type. So this is part of the difference between types and interface. There is no one over the another. We're gonna see that later on, how convenient it is for us to use now interface to describe now declaration of shape of your systems across different places and mash them together to enhance now this functionality. That makes a ton of sense. So this is part of the objects here, right? And in looking at also the continue to looking at the object is how these objects behave. So for example, how you can now is dynamically describe what are the possible values that a key can be, right? Okay, how can you restrict that? So for example, it's using now the key in, and you provide the literals for that. Also, you define is the optional values or exact optional values or required values, and how you can define optional keys, all right, and how you can use some of the convenience built-in features from Typescript, like partial, right, or require. How you can now set a constraint of what are the possible values that this key can be, all right, and that is very useful, by the way, when working with that, right? And sometimes you want is pick elements or omit elements to create now a new type or a new interface. And how now the omit is loosely, and the partial and the pick is now it provides you this auto completion feature. Okay, so that's great. So far so good, because this is how you can describe is the behaviors of objects using now Typescript. And I think this is so it makes a lot of sense for us to do that, so we can master this. So excluding fields from Typescript here, we exclude that, for example, using now the omit, or not only yeah, it's using the omit. All right, so you want to exclude keys on these objects and just get only the relevant one. Or if you want to now, this is for excluding, or to make them require, or to share definitions amongst them. So now finally, to what I really care into this video is the fixing a type assignments or the mutability behaviors. All right, so first we look at how now things like let and const behave in JavaScript, and particularly when you try to now do or to define in a const is the so the TLDR is that in this section of the mutability, I'm looking is at this this key operator in the language in JavaScript, which is a let and var. So let and const particularly, mainly here, right? So because when you use now a const and you try to assign the possible values that this const can be, specifically in objects, so there is a particularly weird behavior that at the end of the day you have to be explicit about how you're going to do that, right? So for example, object property inference, when you're using now this let and const, this is when you use now let in TypeScript to define is to let the TypeScript to inference the type here. So object property inference is gonna be based when you're using now a let based on the Y type that it represents in the JavaScript. But if you use now a const, it's going to select, or it's gonna get the actual value of this, not the type. So there's some convenient things that, for example, is that how you can now is only make sure that your type or the value type can be in one of these possible state using now objects. So that's why you can use now as const that works in any. So for example, if I look at this, right? You can use this now as const. Yep, you can use now is as const to get the value of this. So in other words, mutability here is looking at the particular key operator let and const and how they behave with objects and with primitive and objects. All right. So here creating this read-only property is also a nice little convenient thing, because sometimes we don't want to mutate the value of a identifier or a variable. So what we do is in JavaScript we can do that at runtime using now the object.free. So anytime that you try to modify the value of this object or this identifier, it won't allow you to do that. This works only at the first level, but we also have now in TypeScript is a utility that is the read-only, that is make very convenient for us as developers to now indicates to ourselves to ourselves from 6 months of our future self and others, our future self and others, our future so as a way to indicate to our future self, or to future proof ourselves and others about this data, right? Hey, I don't want you to mutate this data, so put it now at read-only that works on the build time, not at runtime. So that's fine, right? Because this is how you can create this read-only property. How convenient it is for us to make this read-only property. How you can apply this read-only property using how you can apply these read-only properties here, okay? Using is now the as const, which is again is looking at how the let typings behave and how now TypeScript infer those types, and then at the const keyword and how that TypeScript behave instead of inherit the type or inference the type. It's inferring is the a value here, and how you can use that with objects, right? And how you can now create read-only from that, and how you can apply that from that as well. And how you can exactly how you can compare that with the object.freeze, which makes a ton of sense for this. Absolutely, yeah, absolutely. And why object.freeze is not convenient, because, well, at the end of the day,
Const.
It just works at one level. That's the main issue there, you know. But with Const is now apply this read-only property or freeze this object from mutations across different nested layers. That's great. And then how you can now prevent mutations in array. All right. So whether it's by using now is a read-only in the array, or a utility function that say array read-only.
In this exercise,
Let me see if this actually works. It is. I think it's. In fact, let me read at the docs here, which is.
okay, let's take a look at both solutions. The first solution is.
So is the mutations type manipulations, mutation basic everyday, narrowing to classes and models. Reference, utility cheat sheet, decorators declaring here. Let me see if I can find them. Type inference. Okay. Okay, exactly. Best common type inference, best common type, contextual typing. Okay. Type inference, variable declarations. Okay, which is kind of what we are looking at this. Var and let versus const, destructuring, arrow destructuring functions, declarations, spread using declaration, await using declaration. Defining an asynchronously, await using versus await await using versus await. Because this is part of the new await keyword that is part of the await using declaration only indicate that the disposal of the resource is awaited. It does not await the value itself. The await keyword that is part of the await using declaration only indicates that the disposal of the resource is awaited. Okay. And awaited using and return. Okay. And again, because this is now new features that are introduced to the language as well. Using and await using in for or for of statements. Both using and await using and can be using for statement. And using and await using in older runtimes. Again, this is part of this new declaration. Using declaration. It is stage 3 explicit research management. I think this is part of it. This proposal has been submitted the async explicit research management. Okay. For research management. It is still on status 3, but it was part of this async explicit research management here. Okay, explicit research management proposals like this. This proposal intends to address a common pattern in software development regarding their lifetime and management of various research. This pattern generally includes the allocation of research and the ability to explicitly release critical research. Okay, and the ability, again, that go beyond the scope of today's video. Avoiding common footgun when managing research. Stream.getReader, reader.release lock. Oops, should have been in a try finally. Scoping research. Avoiding common footguns when managing multiple research. And potential for use with this. And again, exactly all of this. So now TypeScript and JavaScript is heavily influenced now with language like this. C#, using a statement here. Right? So for example, like this. So this is why I make this kind of recap to kind of understand where we are and how at which point we are currently at. In Java, try resource statement, and Python with statement here. So again, this go beyond the scope of today's video because the intention is just to explore is the resource for that, right? And by the resource, I mean is what it is. Oh my God, is the model itself here. Is this particular model here on mutations. So if I want to look at the mutations, I just want to make myself familiar with this, the theory, the guides. Do you describe anything related to that description, declaration files, JavaScript, mutation? Do you have anything related to mutations? Get started, handbook. Do you have anything related to mutations, right? Models reference, or how you can annotate types, for example, so object types here. More on functions. No, I want to look at the arrays particularly. Yep. Oh, there you got it. Exactly. So the array, right? This is how you can type in the array. How you can make now an array read only, or to prevent its mutations, mutability, right? Yep. The mutability here with read only, or with the read only array as well. Also, how you define is now tuple, which is at the end of the day they are like an array, right? And how you can extract the value of those via the read only tuples here, right? You cannot assign 0 because it is a read-only property. So that is okay. Distinguish assignability between read-only and mutable arrays here. Fixing on safe tuple.
Now that we know about read-only arrays, it's important to distinguish between what's assignable to what. We have two functions here called printNames read-only, printNames mutable. They're absolutely identical. They both take in an array of names, except printNames read-only takes in a read-only array of names. We're using the read-only modifier here, whereas printNames mutable takes in a mutable array of names. Then down the bottom here, we can see that if we declare a mutable array of names, a bunch of an array that we can push to, then we can actually pass these to the read-only one, and we can pass it to the mutable one. That's because the read-only one is only guaranteeing that it's not going to change the names, right? That's what you say when you sort of hover over this. You see, okay, it expects a read-only array of strings. It doesn't matter if we pass a mutable array of strings because we're not going to touch them anyway. Whereas the other way around doesn't work. If we have a read-only names array here, which we're declaring as const, because we can declare them as const, very cool. This means this array is now read-only John, Jane, and Mike. Then it means that we can only pass them into the read-only slot. If we pass them into the mutable slot, then we're basically saying that we might change this array, we might add stuff to it, we might fiddle around with it, and this means that we get an error here saying argument of type read-only John, Jane, Mike is not assignable to a mutable parameter of type string. You can see up here, yeah, it cannot be assigned to the mutable type string. So TypeScript used this kind of like mutable stuff too. So this is how you should think about it. Read-only is only assignable to other read-only types. And this means that, of course, like read-only is kind of viral in your application. If you have a function way down the call stack that expects something to be read-only, then you're going to make sure that that needs to be read-only all the way up, because it needs to guarantee that it's not going to be mutated any way down the stack. So this is basically how you can think about read-only arrays in TypeScript. Read-only arrays are not assignable to mutable arrays, but it does work the other way around. In this exercise, we have a dangerous function here that takes in an array of numbers. And we have up at the top here, we have a coordinate, right? And a coordinate is a tuple. It's a tuple of two members here, so it has number and number there. And then we have const my house is a coordinate, and it's basically just this tuple here. But there's something really kind of horrible happening here, which is we have our dangerous function, which we basically pass in my house to it. We pass in this coordinate, and inside the dangerous function, it's actually going to pop two of the members here. And pop removes the last element from an array. So this means that just by calling dangerous function on my house here, it means that when we go to access my house, so my house 2 like this, or let's say my house 1, const example equals my house 1, this means that example is actually not going to be number, it's going to be undefined, because after calling dangerous function on my house is going to have length of 0. This is really annoying, a sort of annoying little property of TypeScript, but there is something we can do to make this error go away. Your job is to try to find a better type for coordinate up here to basically make it so that we can't pass it into this dangerous function. The dangerous function has got to stay exactly the same. We're basically just looking for this TS-expect error to trigger for there to be an error when we try to pass my house into this dangerous function. Good luck.
Yeah, it's pretty much like saying they read only here, or at least in this tuple here. So this tuple, it'll be now read only, right? So now I can make sure, this is now to look at another behaviors here, which is on the tuple. So when you're now assigning here, which is a read only operation, and if you're trying to now pass this, unfortunately this won't work, and I don't know why it won't work. I think this is some issues I have now this. But in any case, but yeah, the only thing that you need to do here in that exercise is just that one. Let me take a look at what is that. Is 104? Yeah, exactly. So 104 is just to say, hey, read only. So now TypeScript say is, hey, if you're about to pass this type, so make sure that you are not, because this cannot be modified down the line. All right, and again, this is just to describe is the behavior of mutability in arrays, and as well as this of the two possible behaviors that we can have in arrays, like the array of an unknown length, all right, known as a list, or as a tuple, when you have now this as a fixed length, but each one of those elements can be a different types, right? So you can think of this like a basket, when in this each one of those slot that this basket is defining that this is the side of this collections, and each one of those baskets I can pull things like bananas, or one of the apples, and the other thing is some penicillin. I don't know why, but well, you love it. But that's what it is, right? So this is how you fix this particular error here. Okay, I get it. But it's that, and also the notion that when you're now defining is immutable or immutable or mutable arrays. So that immutable array, it needs to be the same all the way down in your stack. Yeah, that makes a lot of sense here. That makes a ton of sense.
Okay, what is the
TLDR of all of this is that I am just learning is the intention of the Typescript authors based on his experience of developing this kind of applications at scale, and that is at C#.
property of read-only arrays is that the includes and index of method don't really work as you'd expect on them. So we have this users array here, and this users array, we're declaring it as const, and so it's inferred as a read-only array containing Matt, Sophia, and Vakas in that order. And then we call users.includes Brian on there, and because Brian is not a member of this array, then it's going to error at us. And same thing here with index of. Okay, that's a little bit annoying, and this is annoying in a bunch of different ways, and really it's annoying because you want to check whether, let's say, a string conforms to three things that you know already. So let's say you have a bunch of URLs that you can sort of like whitelist against, or allow list against, and then you can want to check if the URL that's being passed in and validate it against those. This just gets pretty annoying, and there is a way that you can fix this or make this a little bit better, which is using a tool that I've created called Total TypeScript TS Reset. You can import this into your project, import it in one line, and it globally affects some of the types in TypeScript, and instead of includes now requiring it to be either Matt or Sophia or Vakas, when we uncomment this, we can see that it is just string. So
okay, so it's going to look at that and modify that signature here.
it sort of defaults to the wider type there. This is really useful, and it means that you can kind of use these with a bit more really work as you'd expect on them. So we have this users array here, and this users array, we're declaring it as const, and so it's inferred as a read-only array containing Matt, Sophia, and Vakas in that order. And then we call users.includes Brian on there, and because Brian is not a member of this array, then it's going to error at us. And same thing here with index of. Okay, that's a little bit annoying.
But this is actually telling you that, hey, you define this user as an immutable. So why would you do that? That's the whole point of this. Is like, this is at the end of the day is an immutable array. All right? Right? Exactly. It's an immutable array. Why would you want to mutate in this array? You know what I mean? There you got it.
That order. And then we call users.includes Brian on there, and because Brian is not a member of this array, then it's going to error at us. And same thing here with index. It conforms to three things that you know already. So let's say you have a bunch of URLs that you can sort of like whitelist against, or allow list against, and then you can want to check if the URL that's being passed in and validate it against those. This just gets pretty annoying, and there is a way that you can fix this or make this a little bit better, which is using a tool that I've created called Total TypeScript TS Reset. You can import this into your project, import it in one line, and it globally affects some of the types in TypeScript, and instead of includes now requiring it to be either Matt or Sophia or Vakas, when we uncomment this, we can see that it is just string. So it sort of defaults to the wider type there. This is really useful, and it means that you can kind of use these with a bit more flexibility and just with a single import. So this is like a really, really useful tool in your tool set. It sometimes makes TypeScript a bit stricter. Sometimes here makes it just a little bit helpfully looser. And you might think, why don't the TypeScript team just use TS Reset in their types? Well, I mean, there's an argument to be made that maybe this is the right situation, given that this is, a bunch of users, and like you can argue this from both sides, I think. But for me, I prefer just having like the wider version of this, and so TS Reset is a really useful tool for that. So there we go. So read-only arrays, includes and index of can be a little bit annoying, so I recommend using TS Reset to smooth that out.
Again, for this specific behavior here. But again, you shouldn't do that, because at the end of the day, that includes is going to okay. So define that as a literal, perhaps. When you wanna okay. So go to the whites here. Again, specific behavior for arrays here.
In this exercise, we have an async fetch data function. What this does is it returns some sort of result. If the result is not okay, it returns a tuple containing the error in the first member of that tuple. And then otherwise, it returns some data, and that data is basically, it then returns undefined in the first member of the tuple, and then returns the data in the second member of the tuple. So you can use it kind of like this, where we say await fetch data, and it's not going to throw an error here. It's actually just going to basically return the error, and the error appears in the end. So it's kind of like a result type. But what we're getting here is that both of these are now being inferred as any. That's really weird. And what I would like you to do is try to find a technique by changing the code inside the fetch data function to basically say, okay, like when we look at this, if we hover over fetch data, it's currently returning a promise with any array, so an array of any. We actually want it to infer a tuple here. So there are two approaches. You could either use a return type, or you could change some of the annotations within this part of the function, so within the return values of the function, so this return value and this return value, and add a little annotation there to see if you could get it to infer a tuple at those positions. Good luck.
But again, this is for this kind of annotations here. Okay, again, a specific behavior. And when you now pass here, right? So here, whether it should be explicit about that, right? Whether it's you're explicit about that, right? When you say, hey, this, when it comes to return possible tuples values, okay, very specific to React here. This, okay, this can be the possible values here. What I can say is just only like this, right, and get rid of that. And just let you to inherit that. Okay, for this specific behavior here. For these specific behaviors, for useful for React.
Okay, the first solution here is to basically add a return type to the fetch data function, and to say, okay, we say promise inside here, and inside the promise we have a tuple that either has error or undefined as the first one, and then in the second member it has any in the second one. So this is what the data is typed at, any. And what we'll get here is error or undefined, which is good, and data is any. This, though, is a little bit cumbersome as a type, and there's a really neat technique that you can use to instead add asQ. So we first return the error and then the data inside here. And so if we hover over fetch data, just adding asConst infers it as a tuple. Super cool.
Again, looking at the behaviors of this immutability or the mutability aspect of the operators like key, like from the mutability aspect of operators like let and const, how they behave with primitive, how they behave with objects, how you can now freeze from mutations at Typescript level using now the read-only property, how you can now get the true value of that, or how now let goes with the widest types, and now const goes with the type literal values, how you can use that, for example, to describe now objects behaviors. All right, like, hey, how can I prevent this object to mutate, right? With it, whether by using as a const. How can I prevent this array, which is a special type of objects, to be mutated? What are the special syntax? How can I prevent now a tuple to be mutated as well? How can I exactly, and the difference now with the read-only and mutable arrays, right? And fixing unsafe tuples, right? How convenient is for us to sometimes use that improved type inference for async function. So to get the for returning functions, to get now as a tuple, okay. And then the other is first string as their literal types in object with const.
I wanted to show you one more interesting property of asConst. We have our modify button function here, which takes in our button attributes, which has a type of button, submit or reset, and we have our const button attributes down here, which is an object with type button. And of course we know that this is being inferred as type string, but modify button expects an object with type button, submit or reset. Now we can of course fix this error by just using asConst on the entire object and saying button attributes is now totally asConst, and this means that type is now read-only as well as being inferred as its literal. But we can also remove that and just say type button asConst, and we can say now that button is inferred as its literal type. So we can hover over this and we can see now that it's type button. You notice that it's slightly different from when I put the asConst down here, where when I put it there, it's read-only type button because the entire object is basically inferred as read-only. Whereas like this, it's basically just saying infer this literal string as its literal. This is really cool, and we can do that further down too. So if we have our type and type down here, we can say asConst down the bottom here. This is like an array of objects, and now in this array of objects, type button is being inferred as type button, and type submit is being inferred as type submit. So this is really nice when you just want to make sure a string or a number or a boolean is being inferred as its literal. And it's odd because, of course, we can still modify this, right? So we say button attributes.type equals, we can only modify it to be button, but we still can modify it, which is a curious thing. So this is another tiny little use case for asConst that you should just keep in the back of your mind anytime that you want to make sure that an object that you declare, just that literal, is inferred as const. Quite handy.
Absolutely. And that'll be all for this video. Take care. Bye-bye.